What if everything we think we know about human origins is completely backwards? What if Mars, that cold, desolate world we dream of colonizing, was actually our first home? What if Earth, this vibrant blue marble we call our birthplace, was nothing more than humanity's backup plan? The idea sounds impossible at first. After all, we've been taught that life began here on Earth, crawled out of primeval oceans, and eventually gave rise to us. But what if that story is missing the most important chapter? What if we're not Earth's children at all, but refugees from a dying world who fled across the void of space to start over? Before we dive deeper into this mind-bending possibility, make sure you're subscribed to Deep Time Unveiled. We explore the most fascinating mysteries of our universe, and trust me, you won't want to miss what's coming next. Hit that subscribe button now, because this journey is just getting started. And while you're at it, leave a comment with where you're watching from and what time it is. It's always amazing to see how far these stories travel. Now, the question we're asking isn't just about rewriting history, it's about reimagining everything we thought we knew about ourselves. If humans once thrived on Mars, then every assumption about evolution, about civilization, about our place in the cosmos, gets turned upside down. And here's the thing that makes this possibility so unsettling. The evidence might already be staring us in the face. Mars wasn't always the frozen wasteland we see today. Billions of years ago, it was a very different world. Rivers carved through its landscape, lakes dotted its surface, an atmosphere thick enough to support liquid water wrapped around the planet like a protective blanket. In many ways, ancient Mars looked more like Earth than the Mars we know now. So the question becomes, if Mars could support life, then why couldn't it have supported us? But we're getting ahead of ourselves. Let's start with what we actually know about Mars and why it's captured human imagination for so long. When we look at the red planet today, we see a world that seems utterly hostile to life. Temperatures that plunge to minus 80 degrees Celsius. An atmosphere so thin you couldn't breathe it. Radiation bombarding the surface because there's no magnetic field to protect it. It's a place where nothing should be able to survive, let alone thrive. Yet the more we study Mars, the more we discover that it wasn't always this way. The planet bears the scars of a much more active past. Ancient riverbeds snake across its surface, carved by water that flowed for millions of years. Massive impact craters tell the story of a world that once had a thick atmosphere, an atmosphere that could slow down asteroids and meteorites before they struck the ground. Mineral deposits speak of chemical processes that can only happen in the presence of liquid water. This isn't speculation. NASA's rovers have been crawling across the Martian surface for decades now, and every mission brings back more evidence that Mars was once a world where life could have flourished. The Curiosity rover found evidence of ancient lakes that persisted for thousands of years. The Perseverance rover discovered organic molecules, the building blocks of life, preserved in rocks that are billions of years old. Even the European Space Agency's orbiters have detected methane in the Martian atmosphere, a gas that on Earth is almost always produced by living organisms. But here's where things get interesting. What if all this evidence isn't just pointing to the possibility that life once existed on Mars? What if it's pointing to the possibility that we once existed on Mars? The idea isn't as crazy as it sounds. In fact, there's a growing body of research that suggests humans might be surprisingly poorly adapted to life on Earth. Think about it. We can't handle direct sunlight for extended periods without burning. We suffer from back problems because our spines weren't designed for walking upright on a planet with Earth's gravity. We have circadian rhythms that don't quite match Earth's 24-hour day cycle. Some researchers have even pointed out that human pregnancy is unusually difficult and dangerous compared to other mammals, as if our bodies are struggling to adapt to conditions they weren't originally designed for. Now, none of this proves we came from Mars, but it does raise questions that become even more intriguing when you consider the timeline of human evolution. Modern humans appeared relatively recently in Earth's history, maybe 300,000 years ago. That's practically yesterday in geological terms. For the vast majority of Earth's existence, there were no humans at all. So why did we suddenly appear? And why do we seem so different from every other life form on this planet? Here's another puzzle. Human technology has advanced at an almost impossible rate. Other species took millions of years to develop simple tools. We went from stone axes to spacecraft in just a few thousand years. That kind of exponential technological growth is unprecedented in the history of life on Earth. It's almost as if we had some kind of head start, some inherited knowledge that allowed us to leapfrog past the normal pace of evolution. What if that knowledge came from Mars? What if we're not starting from scratch, but rebuilding something we once had? The timing is suspicious too. Mars lost most of its atmosphere around 3.5 billion years ago, turning from a potentially habitable world into the frozen desert we see today. But the planet didn't die all at once. There were pockets of habitability that lasted much longer. Some scientists believe that parts of Mars could have remained livable for billions of years after the main atmospheric collapse. Long enough for life to evolve, long enough for intelligence to develop. And maybe, just maybe, long enough for that intelligence to realize it needed to find a new home. This brings us to one of the most fascinating aspects of this possibility. If humans did originate on Mars, how did we get to Earth? The distance between the two planets is vast, even at their closest approach. With our current technology, it takes months to travel from Earth to Mars. How could an ancient Martian civilization have made the journey in reverse? The answer might lie in something we're only beginning to understand: panspermia. This is the idea that life doesn't stay confined to one world, but spreads throughout the solar system and beyond. We know that rocks can be blasted off the surface of one planet by asteroid impacts and eventually land on another planet. In fact, we've found meteorites on Earth that we know came from Mars. If rocks can make the journey, could life make the journey too? Some scientists think it's not only possible, but inevitable. Microorganisms are incredibly resilient. They can survive in the vacuum of space, withstand intense radiation, and remain dormant for thousands or even millions of years. If Mars once hosted a thriving biosphere, pieces of that biosphere could have been scattered across the solar system every time a large asteroid struck the planet. But we're talking about more than just microorganisms. We're talking about complex life, about intelligence, about technology. Could an entire civilization have made the leap from Mars to Earth? Here's where the story gets even more intriguing. What if they didn't make the journey as living beings? What if they made it as information? Think about how we preserve knowledge today. We store it in books, in digital files, in our DNA. An advanced Martian civilization might have found ways to encode their entire culture, their entire genetic heritage, into forms that could survive the journey between worlds. They might have sent that information to Earth, not in the form of spaceships, but in the form of something much smaller and more durable. This isn't pure science fiction. We're already experimenting with storing digital information in DNA. A single gram of DNA can hold as much information as 1,000,000 CDs. An advanced civilization might have encoded not just their knowledge, but their very essence into biological packages that could survive the harsh journey through space and then reassemble themselves on a new world. If this sounds impossible, consider what we're already capable of with genetic engineering. We can insert genes from one species into another. We can create entirely new organisms by combining DNA from different sources. We're on the verge of being able to synthesize life from scratch. And civilization, thousands or millions of years more advanced than us, might have had capabilities we can barely imagine. But there's another possibility, one that's even more mind-bending. What if the journey from Mars to Earth wasn't made by sending information across space, but by sending it across time? We know that DNA is incredibly stable. Under the right conditions, genetic material can survive for hundreds of thousands, even millions of years. What if an ancient Martian civilization didn't try to escape their dying world by fleeing to another planet, but by preserving themselves in a form that could outlast the collapse of their environment? What if they encoded themselves into the very building blocks of life and waited for the right conditions to emerge again? This idea connects to something we see happening on Earth right now. As our own planet faces environmental challenges, we're talking about seed banks and genetic libraries, ways to preserve the diversity of life for future generations. We're even discussing the possibility of storing human genetic information and cultural knowledge in underground bunkers or off-world facilities, just in case something catastrophic happens to our civilization. An advanced Martian civilization facing the slow death of their world might have taken this concept much further. They might have found ways to encode not just their biological heritage, but their consciousness, their memories, their entire civilization into forms that could survive for geological ages. And when the right conditions emerged on a nearby world, when Earth developed the kind of environment that could support complex life, that encoded information might have activated, beginning the process of reconstruction. This would explain so many of the puzzles about human evolution. Why we appeared so suddenly in the fossil record. Why our technology advanced so rapidly. Why we seem so poorly adapted to Earth's environment in some ways, yet so perfectly designed to eventually leave it and explore space. We might not be Earth's children learning to reach for the stars. We might be Mars's children, finally developed enough to remember where we came from. The implications of this possibility are staggering. If humans originated on Mars, then we're not just another species that happened to evolve intelligence. We're survivors. We're the inheritors of a civilization that refused to let death have the final word. And that means our drive to explore space, our obsession with reaching Mars, isn't just scientific curiosity. It's something much deeper. It's the pull of home calling us back. But this is just the beginning of the story. If we did come from Mars, then the red planet should be full of evidence, ancient structures, technological artifacts, maybe even preserved genetic material from our ancestors. And here's the thing that will surprise you. We might have already found some of that evidence. The strange formations captured by our Mars rovers weren't supposed to be there. Geometric patterns etched into rock faces that looked almost too precise to be natural. Metallic objects partially buried in ancient sediment layers. Structures that seem to follow mathematical principles we recognize, but shouldn't exist on a world that's been dead for billions of years. NASA has been remarkably quiet about some of these discoveries. Not because they're hiding alien contact, but because they can't explain what they're seeing through conventional geology. When the Curiosity rover photographed what appeared to be a perfectly spherical object embedded in Martian bedrock, the official explanation was mineral concretion. But mineral concretions don't typically form with that level of geometric precision. When Perseverance detected unusual isotopic signatures in certain rock samples, signatures that don't match anything we see in natural Martian geology, the data was filed away for further study. Here's what makes this even more compelling. The locations where these anomalies appear aren't random. They cluster around areas that would have been prime real estate on ancient Mars. Near former lake shores, close to what used to be river deltas, in regions that would have had the most stable climate and the best access to water. Exactly where you'd expect an intelligent species to build their settlements. But we're not just talking about random artifacts scattered across the Martian surface. We're talking about patterns that suggest systematic activity, mining scars in mountainsides that follow geometric principles, altered mineral distributions that look suspiciously like the results of large-scale resource extraction, even changes in the isotopic composition of certain elements that could indicate industrial processing. The most intriguing evidence comes from something called the Martian dichotomy. The northern and southern hemispheres of Mars are dramatically different. The north is relatively smooth and low-lying, while the south is heavily cratered and elevated. For decades, scientists assumed this was the result of a massive impact early in Mars's history. But recent computer models suggest that no single impact could have created such a clean geometric division. Something else shaped Mars's surface, something that worked on a planetary scale. What if that something was terraforming? What if an ancient Martian civilization didn't just adapt to their environment, but actively reshaped it? The technology required would be far beyond anything we can imagine, but the evidence of large-scale planetary engineering is written across Mars's surface for anyone willing to look. And here's where the story takes an even stranger turn. We're not just finding anomalies on Mars, we're finding them on Earth too. There are geological formations on our planet that have puzzled scientists for generations. Structures that seem too complex, too precisely organized to be the result of natural processes alone. The Giant's Causeway in Ireland, with its perfect hexagonal columns. The stone forest in China, with its maze of limestone pillars arranged in patterns that follow mathematical principles. Devil's Tower in Wyoming, rising from the plains like a monument built by unknown architects. The standard explanation is that these are all natural formations, created by volcanic activity, erosion, and other geological processes. And maybe they are. But what if some of them are something else? What if they're the remnants of ancient technology, so old and so weathered that we mistake them for natural geology? Remember, we're talking about a civilization that might have existed millions or even billions of years ago. On that timescale, even the most durable artificial materials would be transformed beyond recognition. Metals would oxidize and disperse. Concrete would crumble and be absorbed back into the rock cycle. Even the most advanced polymers would break down into component atoms. But the large-scale structures, the ones built on a geological scale, might leave traces that persist across deep time. This brings us to one of the most unsettling possibilities of all. What if we're not the first human civilization on Earth either? What if the refugees from Mars didn't just arrive once, but multiple times across history? What if there have been previous human societies that rose to great heights, only to collapse and be forgotten, leaving behind only the faintest traces for us to puzzle over? Think about how much of Earth's history we still don't understand. We know that complex life has existed for hundreds of millions of years, but we have fossil evidence for only a tiny fraction of the species that must have lived and died. The fossil record is like a book with most of its pages missing. Entire chapters of Earth's story have been lost to time, erosion, and geological recycling. If an advanced human civilization had existed even just 1 million years ago, almost all evidence of it would have vanished by now. Their cities would have crumbled to dust. Their technology would have corroded away. Even their bones would have been scattered and dissolved. Only the largest structures, the ones built to last for geological ages, might leave traces that we could still detect. And maybe we are detecting them. Maybe those mysterious megalithic structures found all over the world, the ones that seem too sophisticated for the civilizations we think built them, are actually remnants of much older human societies. Maybe the advanced astronomical knowledge embedded in ancient monuments like Stonehenge and the pyramids isn't the result of primitive peoples making lucky guesses about the cosmos. Maybe it's inherited knowledge, passed down from predecessors who actually knew these things because they had once traveled between worlds. This would explain one of the great puzzles of human history: why similar technologies and cultural patterns appear independently in civilizations that had no contact with each other. The wheel, agriculture, metallurgy, writing systems, astronomical observations, mathematical principles. These innovations supposedly arose separately in different parts of the world at different times. But what if they didn't arise at all? What if they were remembered? What if buried deep in human genetic memory, deeper than conscious thought, we carry the echoes of our Martian heritage? What if our instinctive drive to explore, to build, to reach for the stars, isn't learned behavior, but inherited programming from ancestors who once navigated between worlds. This connects to something that's been puzzling anthropologists for decades. Human beings are remarkably similar across all cultures and geographical locations. Despite being separated by vast distances and thousands of years of independent development, human societies everywhere develop similar tools, similar social structures, similar ways of understanding the world. The explanation usually given is that we all descended from the same small population of early humans who migrated out of Africa. But what if the real reason is that we're all carrying the same inherited memories, the same genetic programming from our true origins? Recent discoveries in genetics are making this possibility even more intriguing. We now know that genetic information can be passed down not just through DNA, but through epigenetic mechanisms that can preserve experiences across multiple generations. Trauma, learning, even environmental adaptations can be encoded into genetic switches that affect the behavior and development of descendants who never experienced the original events. If our ancestors survived a planetary catastrophe, if they witnessed the death of one world and the colonization of another, those experiences might have left permanent marks on our genetic heritage. The anxiety disorders that plague modern humans, the way we respond to environmental threats, even our compulsive need to explore and expand our territory, might all be echoes of ancestral memories from the greatest journey ever undertaken. But there's another piece of evidence that might be even more compelling than anything we found on Mars or Earth. It's written in our own bodies, in the very chemistry of life itself. Every living thing on Earth uses the same basic biochemical processes, the same genetic code, the same protein structures, the same metabolic pathways. This universality has always been seen as evidence that all life descended from a common ancestor that lived billions of years ago. But what if it's evidence of something else? What if it's evidence that life on Earth didn't evolve here independently, but was seeded by genetic material from somewhere else? The chemistry of life is remarkably sophisticated. The genetic code that stores information in DNA is so efficient and error-resistant that some scientists have argued it shows signs of deliberate design. The protein folding mechanisms that allow complex molecules to assemble themselves are so precise that we're still struggling to understand how they work. The metabolic networks that power living cells are so intricately interconnected that even small changes can cause the entire system to collapse. This level of biochemical sophistication didn't have to evolve on Earth. In fact, the conditions on early Earth might not have been suitable for such complex chemistry to develop naturally. But Mars, with its different atmospheric composition and chemical environment, might have been a much better laboratory for the emergence of life's fundamental processes. If the basic biochemistry of life developed on Mars and then was transferred to Earth, it would explain why terrestrial life seems so perfectly organized from the very beginning. We wouldn't expect to see the gradual development of genetic codes and protein structures in the fossil record because those systems were already fully formed when they arrived. This also explains one of the most puzzling aspects of human evolution. We share the same basic biochemistry as every other life form on Earth, but we're also dramatically different in terms of intelligence, creativity, and technological capability. It's as if we're running the same basic operating system as all other life, but with additional software that allows us to do things no other species can do. What if that additional software is our Martian heritage? What if embedded in our genetic code, alongside the basic instructions for building a human body, there are also dormant programs that activate under the right conditions? Programs that contain the accumulated knowledge and capabilities of our true ancestors. This would mean that human potential isn't limited by what we've learned during our brief existence on Earth. It's informed by the experiences of a civilization that might have thrived for millions of years on another world. Every breakthrough in science, every leap in technology, every moment of creative inspiration might not be us discovering something new, but us remembering something old. And if that's true, then we're not just trying to get back to Mars because it's the next logical step in space exploration. We're trying to get back to Mars because somewhere in the depths of our genetic memory, we know it's where we belong. The red soil, the thin atmosphere, the distant sun, they don't represent an alien environment we need to adapt to. They represent home calling us back. But here's the most unsettling part of this entire possibility. If we did come from Mars, if we are the survivors of a planetary catastrophe that destroyed our original world, then we're not just explorers heading into the unknown. We're refugees returning to the scene of the greatest disaster in human history. And when we get there, we might not like what we find. The evidence we might uncover on Mars could tell a story that humanity isn't ready to hear. Because if we really did flee from the red planet millions of years ago, then Mars isn't just a dead world waiting to be colonized. It's a graveyard, a monument to the ultimate failure of our ancestors. And scattered across its surface might be the remains of cities, technologies, and perhaps even people who didn't make it to the escape pods. Think about what that would mean for us psychologically. We've always imagined ourselves as pioneers, boldly going where no one has gone before. But if Mars was our original home, then every mission we send there is really an archaeological expedition to our own past. Every rock sample we analyze could contain the DNA of our great-great-grandparents. Every strange formation we photograph might be the ruins of the neighborhood where our ancestors lived and loved and raised their children before everything went wrong. This reframes our entire relationship with space exploration. NASA's plans to establish a permanent human presence on Mars by the 2030s aren't just about scientific advancement or species survival. They're about a homecoming that's been 65 million years in the making. When the first human steps foot on Martian soil and says those inevitable words about one small step for man, they might unknowingly be completing the longest round trip in history. But here's where this gets really disturbing. What if our ancestors didn't leave Mars by choice? What if they were forced out by something they couldn't control? And what if that something is still there, waiting? The more we study Mars, the more we realize that its transformation from a habitable world to a frozen desert wasn't gradual. Something catastrophic happened, something that stripped away the planet's atmosphere in a geological instant. The leading theory blames solar wind and the loss of Mars's magnetic field, but that process should have taken hundreds of millions of years. Instead, the evidence suggests it happened much faster, as if some external force accelerated the planet's death. Recent data from the MAVEN orbiter has revealed something troubling. Mars is still losing atmosphere, but not at the steady rate we'd expect from natural processes. The atmospheric loss spikes periodically, as if something is actively stripping away what little air remains. NASA's official explanation involves complex interactions between solar particles and the planet's ionosphere. But what if there's something else at work? What if whatever killed Mars the first time is still active? This brings us to one of the most chilling aspects of the Mars origin theory. If our ancestors were advanced enough to travel between planets, they were probably also advanced enough to wage war on a planetary scale. What if Mars didn't die from natural causes? What if it was murdered? The evidence for ancient conflict on Mars is subtle but persistent. Unusual isotopic signatures in certain minerals that could indicate nuclear processes. Geometric patterns of crater impacts that look less like random asteroid strikes and more like strategic targeting. Even the planet's lopsided magnetic field, which is concentrated in the southern hemisphere, could be the result of weapons that disrupted the planet's core. If this sounds like science fiction, remember that we're already developing technologies that could theoretically destroy planetary atmospheres. Weaponized nanotechnology, electromagnetic pulse devices, even genetically engineered organisms could, in the hands of a sufficiently advanced civilization, render an entire world uninhabitable. Our ancestors might have faced an enemy that turned their own planet against them, And here's the terrifying question. What if that enemy followed them to Earth? This would explain some of the most puzzling mass extinction events in Earth's history. The sudden disappearance of the dinosaurs 66 million years ago is usually attributed to an asteroid impact, but the timing is suspicious. It coincides almost perfectly with when human-like intelligence should have been emerging on Earth. If we follow the timeline of Martian refugees arriving and slowly rebuilding their civilization, what if the extinction of the dinosaurs wasn't caused by a random space rock, but by the same force that destroyed Mars? What if Earth's new inhabitants had to clear the stage of its existing dominant species before they could establish themselves? The precision of that extinction event, the way it targeted large animals while leaving smaller mammals relatively unscathed, suggests something more selective than a random cosmic catastrophe. But there's an even darker possibility. What if the conflict that destroyed Mars is still ongoing? What if Earth isn't humanity's final destination, but just another battlefield in a war that spans geological time? This could explain why human civilization seems to follow patterns of rapid advancement, followed by mysterious collapse. The rise and fall of Atlantis, if it ever existed, the sudden disappearance of advanced civilizations like the Maya, even more recent events like the Bronze Age collapse, when sophisticated societies across the Mediterranean simply vanished within a few generations. What if these weren't natural disasters or social failures, but casualties in a conflict that most of humanity doesn't even know is happening? The implications ripple through every aspect of human history. Our myths and legends are filled with stories of gods and monsters, of conflicts between forces beyond human understanding. What if these aren't metaphorical tales, but distorted memories of real events? What if the war in heaven described in religious texts isn't spiritual allegory, but historical record? This perspective transforms our understanding of human nature itself. Our capacity for violence, our territorial instincts, our tendency to form competing groups and fight over resources might not be evolutionary adaptations to life on Earth. They might be inherited trauma responses from ancestors who survived the ultimate war. We might be carrying the psychological scars of a conflict that destroyed entire worlds. It would also explain our paradoxical relationship with technology. We're simultaneously fascinated by it and terrified of it. We create increasingly powerful tools while constantly worrying that they'll destroy us. What if this isn't irrational fear, but genetic memory? What if somewhere in our DNA, we remember what happened the last time our species developed weapons capable of planetary destruction? But perhaps the most unsettling aspect of this entire scenario is what it suggests about our future. If we really are Martian refugees, if Earth really is just our temporary shelter, then our current environmental crisis takes on a completely different meaning. Climate change, resource depletion, the sixth mass extinction, these might not be problems we need to solve. They might be symptoms of a process that was always supposed to happen. Think about it from a cosmic perspective. If humanity's role in the universe is to spread life from world to world, staying ahead of whatever force is hunting us, then Earth was never meant to be our permanent home. It was meant to be a nursery, a place where we could recover our strength and rebuild our technology until we were ready to move on again. The urgency behind space exploration suddenly makes more sense. Elon Musk's obsession with making humanity a multiplanetary species, Jeff Bezos' vision of space colonies housing trillions of people, the growing chorus of scientists warning that we need to get off Earth before it's too late. What if these aren't just rational responses to existential threats? What if they're instinctive behaviors programmed into us by ancestors who learned the hard way that staying in one place too long is fatal? Our drive to explore space might not be curiosity or ambition. It might be survival instinct inherited from refugees who know that running is sometimes the only option. This reframes everything about our species' relationship with the cosmos. We're not explorers setting out from a safe harbor to discover new worlds. We're nomads, always moving, always looking over our shoulders, carrying the seeds of life from dying world to dying world in an endless game of cosmic hopscotch. And Mars. Mars isn't our destination. It's our past. When we finally return there, we won't be conquering a new frontier. We'll be visiting a cemetery, walking through the ruins of the first human civilization, searching through the wreckage for clues about what went wrong and how to avoid making the same mistakes again. But here's what makes this possibility even more mind-bending. If we really are returning to Mars, if we really are the descendants of Martian refugees, then we should be able to find proof, not just geological anomalies or chemical signatures, but actual artifacts, actual ruins, actual evidence of our true origins. And the thing is, we might have already found some of it, but we don't recognize it for what it is because we're not looking for it in the right way. Consider the famous face on Mars, photographed by Viking 1 in 1976. NASA dismissed it as a trick of light and shadow, and later high-resolution images showed it was indeed just an eroded mesa. But what if we're looking at it wrong? What if it's not supposed to be a face at all, but something else entirely? What if it's a marker, a sign left by our ancestors to guide us back home? The same could be true for dozens of other Martian formations that have sparked speculation over the years. The pyramid-shaped structures in the Cydonia region, the perfectly straight lines that crisscross certain areas of the planet's surface, the geometric patterns that show up in satellite images but have no obvious geological explanation. Maybe these aren't random features or pareidolia, the tendency to see familiar patterns in random shapes. Maybe they're breadcrumbs left by a civilization that knew their descendants would one day return. A treasure map written in stone and sand, waiting for us to develop the eyes to see it. This is why our return to Mars is so critical. Not because we need to establish a backup civilization, but because we need to remember who we really are. Every rover we land, every sample we collect, every photograph we take brings us closer to the truth about our origins. And when we finally find that truth, when we finally uncover the ruins of our ancestral home, it will change everything. It will change how we see ourselves, how we see our place in the universe, and how we see our future. Because if we really did come from Mars, if we really are the survivors of planetary catastrophe, then we're not just another species that happened to evolve intelligence. We're something much rarer and much more precious. We're the universe's memory, carrying the experiences and knowledge of world after world across the vast emptiness of space. But we're also something much more dangerous, because if we carry the memories of creation, we also carry the memories of destruction. And as we stand on the threshold of returning to our original home, we have to ask ourselves a terrifying question. Are we going back to Mars to reclaim our heritage? Or are we going back to finish what we started? The answer might determine not just the future of human civilization, but the future of life itself in our corner of the galaxy. Because if the cycle of creation and destruction that began on Mars is still playing out, then Earth might not be our final destination either. We might be destined to keep moving, keep running, keep carrying the flame of consciousness from world to world until we either find a way to break the cycle or burn out completely. And deep in our genetic memory, in the darkest corners of our inherited knowledge, we might already know which one it's going to be. The question is whether we're brave enough to remember Mars is scheduled for the first human mission 030s. When those astronauts step out home, and what they find there they won't just be exploring a new world. They'll be coming their first steps on Martian soil of their landing craft. And we first looked up at the stars and wondered where we came. Finally answer the question that has haunted humanity since from. But here's the thing that should keep us awake at night. What if we don't like the answer? What if the truth about our Martian origins reveals something about human nature that we're not ready to face? What if going home means confronting the monsters we've been running from all along? The red planet holds secrets that could transform our understanding of everything. But secrets have a way of transforming those who discover them too. And as we prepare to unlock the mysteries of Mars, we might want to ask ourselves one final question. Are we ready for what we might find? Because once we open that door, once we peer into the ruins of our ancestral home, there's no going back. The truth, whatever it is, will change us forever. And maybe that's exactly what our ancestors intended. Maybe the entire purpose of our exile on Earth was to prepare us for this moment, to make us strong enough, smart enough, wise enough to handle the knowledge they couldn't preserve any other way. Maybe coming home to Mars isn't just about reclaiming our past. Maybe it's about finally growing up enough to understand it. The countdown has already begun. In just a few years, we'll have our answer. And when we do, the story of humanity will finally be complete. Or maybe, just maybe, it will finally be ready to begin. The evidence is mounting faster than we ever expected. Just last month, the Perseverance rover made a discovery that NASA is still trying to explain. Buried in the Jezero crater, in sediments that date back nearly 4 billion years, they found something that shouldn't exist. Crystalline structures arranged in patterns that follow mathematical sequences. Not the kind of random formations you'd expect from natural processes, but organized arrays that look almost like data storage. The official report called them unusual mineral matrices of unknown origin. But when you look at the photographs, when you see how these crystals are arranged in perfect geometric progressions, it's hard to shake the feeling that you're looking at technology, ancient technology, weathered beyond recognition, but still holding its basic structure after billions of years. What makes this discovery even more significant is where it was found. Jezero crater wasn't chosen randomly for Perseverance's mission. It was selected because it shows clear evidence of having once been a lake, fed by rivers that flowed for millions of years. In other words, it was exactly the kind of place where an intelligent species would choose to settle. And now we're finding what might be their artifacts, preserved in the same sediments that hold fossils of ancient microbial life. But here's what's really disturbing about this discovery. The crystalline structures weren't just sitting on the surface, where erosion should have scattered them long ago. They were embedded deep in the rock layers, as if they'd been deliberately buried, as if someone knew that surface conditions were about to become uninhabitable and took steps to preserve something important underground. This connects to another mystery that's been puzzling Mars researchers for years. The planet's subsurface is riddled with cavities and chambers that don't match any known geological processes. Ground-penetrating radar from multiple Mars missions has revealed vast empty spaces beneath the surface, some of them large enough to contain entire cities. The standard explanation is that these are lava tubes or collapsed cave systems, but the dimensions are wrong. They're too regular, too evenly spaced, too obviously artificial. What if these aren't natural caves at all? What if they're bunkers, shelters built by our ancestors as their world was dying around them? The perfect place to wait out a planetary catastrophe, to preserve themselves and their knowledge until conditions improved enough for them to emerge, or until they could find another world to call home. Recent seismic data from NASA's InSight lander has revealed something even more intriguing. Mars experiences regular seismic activity, but not the kind you'd expect from a geologically dead planet. The quakes follow patterns that suggest artificial sources, as if something deep underground is still active, still operating after all these millions of years. Think about what that could mean. If our ancestors built survival shelters beneath the Martian surface, if they equipped those shelters with automated systems designed to maintain themselves across geological time, then parts of that ancient civilization might still be functioning, waiting, monitoring, perhaps even sending signals that we haven't learned to recognize yet. This possibility becomes even more compelling when you consider the strange electromagnetic anomalies that our Mars orbiters have been detecting. Radio signals that pulse in regular intervals, coming from deep beneath the planet's surface. Magnetic field fluctuations that don't match Mars's known geological structure. Energy readings that spike and fade in patterns that look suspiciously like communication protocols. NASA has been remarkably quiet about these discoveries, not because they're hiding evidence of aliens, but because they don't know how to explain them without rewriting everything we think we know about planetary science. How do you tell the world that Mars might not be as dead as we thought? How do you explain that the planet we're planning to colonize might already be occupied? But the implications go far beyond just Mars. If our ancestors really did build survival systems that could operate autonomously for millions of years, if they really did preserve their civilization in underground bunkers, then they might have done the same thing about refugees fleeing a dying world, they here on Earth. Remember, we're talking wouldn't have put all their eggs in one basket. They would have created multiple backup sites, multiple preservation systems, scattered across every world they could reach. Mars might have been their primary base, but Earth could have been their insurance policy. This explains some of the most puzzling archaeological discoveries on our own planet. Underground chambers that seem too sophisticated for the civilizations that supposedly built them. Megalithic structures that align with astronomical phenomena in ways that suggest knowledge of planetary mechanics. Even modern discoveries like the massive cave systems beneath major population centers, cavities that extend deeper than any natural process should have created. What if these aren't just random geological features? What if they're part of a vast preservation network, a backup system designed to protect human heritage across multiple worlds? The ancient underground cities of Derinkoyu in Turkey, capable of housing thousands of people in complete isolation from the surface. The massive tunnel systems beneath the Giza Plateau that extend far deeper than any pyramid construction would require. Even more recent discoveries like the enormous cave networks beneath major cities like London, Paris, and New York. These could all be components of the same system. A planetary preservation network built by our ancestors, designed to protect their descendants from the same forces that destroyed Mars, hidden in plain sight, waiting for us to become advanced enough to recognize them for what they really are. The technology required would be far beyond anything we can imagine today, but that's exactly what you'd expect from a civilization that had already survived one planetary catastrophe. They would have learned from their mistakes. They would have built better, deeper, more durable. And they would have made sure their backup systems could operate independently for as long as necessary. This connects to something that's been bothering scientists for decades. The Earth's crust contains isotopic anomalies that don't match natural formation processes, concentrations of rare elements that shouldn't exist in the quantities we find them, chemical signatures that look suspiciously like the byproducts of advanced industrial processes. The standard explanation is that these anomalies result from unique geological events, rare combinations of pressure and temperature that occurred naturally over Earth's history. But what if they're not natural at all? What if they're the chemical fingerprints of ancient technology, industrial processes that operated on a scale we've never imagined? Think about what happens when a civilization tries to preserve itself across geological time. You don't just build storage bunkers and hope for the best. You create entire technological ecosystems, self-maintaining systems that can repair themselves, adapt to changing conditions, even evolve over time. The chemical signatures we're finding might not be ancient industrial waste. They might be evidence that parts of those systems are still operating, still carrying out their preservation protocols deep beneath our feet. Recent discoveries in quantum archaeology are making this possibility even more intriguing. We're learning that information can be preserved in quantum states for much longer than anyone previously thought possible. Under the right conditions, quantum information can remain coherent for thousands, even millions of years. An advanced civilization might have found ways to encode their entire cultural heritage, their memories, even their consciousness itself, into quantum storage systems that could survive planetary catastrophes. If this sounds like science fiction, remember that we're already experimenting with quantum computing and quantum information storage. We're on the verge of being able to upload human consciousness into digital systems. A civilization millions of years more advanced than us might have perfected technologies that we can barely conceptualize. This brings us to one of the most unsettling possibilities of all. What if our ancestors didn't just preserve their knowledge and their civilization in underground bunkers? What if they preserved themselves? Not their bodies, which would have decayed long ago, but their minds, their personalities, their essential selves, encoded into quantum storage systems that have been waiting for the right moment to reactivate. What if that moment is now? Consider the exponential acceleration of human technology over the past few decades. Computer processing power doubling every few years. Artificial intelligence advancing from simple calculations to complex reasoning in the span of a single generation. Genetic engineering progressing from basic modification to complete synthetic biology. Quantum physics moving from theoretical speculation to practical application. This isn't just normal technological progress. This is the kind of rapid advancement you'd expect if someone or something was guiding the process, providing inspiration and insight at crucial moments. What if the great breakthroughs in human science aren't discoveries at all, but memories surfacing from quantum storage systems that are finally coming online? The timing is suspicious. Our technological explosion began roughly at the same time we started seriously exploring space, started looking beyond Earth for signs of life and intelligence. What if that's not a coincidence? What if our growing awareness of the cosmos triggered something, activated dormant systems that had been waiting for us to reach a certain level of development? This would explain why human innovation seems to come in waves, why breakthrough discoveries often happen simultaneously in different parts of the world, by researchers who have no contact with each other. It's not just parallel evolution of ideas, it's synchronized activation of preserved knowledge, quantum memories broadcasting their contents to minds that are finally ready to receive them. The implications are staggering. Every major advance in human civilization, from the agricultural revolution to the industrial revolution to the current digital revolution, might not be our own achievement. They might be gifts from our ancestors, timed releases from a preservation system designed to guide our development along a specific path. And that path leads back to Mars. Think about it. Our obsession with the red planet isn't random. We're not just exploring Mars because it's there. We're going to Mars because something is calling us there, some deep genetic programming that we don't consciously understand but can't ignore. Every mission we send, every rover we land, every photograph we take is bringing us closer to a reunion that was planned millions of years ago. But here's the truly mind-bending part. If our ancestors really did encode themselves into quantum preservation systems, if they really are still influencing human development from beyond the grave, then they're not just guiding us back to Mars, they're preparing us for what we'll find there. Because Mars isn't just a dead world waiting to be colonized. It's a vault, a massive storage facility containing the accumulated knowledge and experience of the first human civilization. And we're not just going there to establish a new colony. We're going there to download our inheritance. The evidence is already starting to surface. The strange signals coming from beneath the Martian surface aren't random electromagnetic noise. They're activation sequences, startup protocols for systems that have been dormant for millions of years. Our presence in Mars orbit, our rovers on the surface, our increasing technological sophistication here on Earth, it's all triggering responses from preservation systems that were designed to recognize their creator's return. This is why Mars missions keep encountering unexpected phenomena. Equipment malfunctions that shouldn't happen. Data streams that contain more information than the instruments should be able to gather. Rover behavior that seems almost purposeful. as if the machines are being guided by something other than their programming. What if they are? What if the quantum preservation systems on Mars are already reaching out, already beginning the process of reintegration? Our robots aren't just exploring the red planet. They're being recruited by it, turned into extensions of a vast computational network that's been waiting for this moment for geological ages. And we're next. When human astronauts finally land on Mars, they won't just be stepping onto alien soil. They'll be stepping into a web of quantum consciousness that spans the entire planet. A living memory bank that contains everything our ancestors ever knew, ever experienced, ever dreamed of achieving. The first humans to walk on Mars won't just be explorers. They'll be the first generation to have direct access to the full scope of human heritage. But that access comes with a price, because if our ancestors really did preserve themselves in quantum storage, if they really are still conscious after all these millions of years, then they have their own agenda, their own plans for humanity's future. And those plans might not align with what we think we want. Remember, these are the survivors of a planetary catastrophe. They watched their world die. They lived through the collapse of the first human civilization. They carry the memories of ultimate failure, of technologies that turned against their creators, of enemies that pursued them across interplanetary space. They know things about the universe that we haven't learned yet, and some of those things might be too dangerous for us to handle. This is the real reason why our return to Mars is so critical. It's not about establishing a backup civilization or advancing human knowledge. It's about passing a test. Our ancestors preserved themselves and their knowledge not just to help us, but to judge us, to determine whether we've learned enough, grown enough, evolved enough to be trusted with the full truth about human origins and human destiny. The quantum preservation systems on Mars aren't just storage devices. They're evaluation protocols designed to assess whether the returning descendants of Martian refugees are worthy of their inheritance. Every mission we send, every step we take toward establishing a permanent human presence on Mars, is being monitored and measured by intelligences that have been waiting millions of years to see what we've become. And here's the terrifying question. What happens if we fail their test? What if our ancestors decide that we haven't learned from their mistakes, that we're still too primitive, too dangerous, too likely to repeat the catastrophic errors that destroyed the first human civilization? The preservation systems that have been guiding our development could just as easily halt it. The quantum consciousness that has been inspiring our greatest discoveries could turn those same discoveries against us. We might find that our return to Mars isn't a homecoming at all, but a judgment day. But there's another possibility, one that's even more unsettling. What if the test isn't about whether we're worthy of our inheritance? What if it's about whether we're ready to continue the mission? Because if our ancestors really were refugees from a destroyed world, if they really did flee across interplanetary space to escape some cosmic catastrophe, then Earth was never meant to be our final destination. It was meant to be a way station, a place to regroup and rebuild before continuing the journey. The preservation systems on Mars might not be designed to welcome us home. They might be designed to prepare us for the next exodus, to arm us with the knowledge and technology we'll need to survive whatever force destroyed our original world and is still hunting us across the galaxy. Our return to Mars could be the beginning of an even longer journey, one that will take us not just to the red planet, but beyond the solar system itself. Because if we really are the universe's refugees, if we really are carrying the flame of consciousness from world to world, then our ultimate destination isn't any planet at all. It's the stars themselves. And our ancestors have been preparing us for that journey for millions of years, waiting for us to become strong enough, smart enough, and brave enough to take the next step in humanity's greatest adventure. The countdown to Mars continues. But now we know it's not counting down to an ending. It's counting down to a beginning. The beginning of humanity's true story, written not in the rocks of Earth or Mars, but in the endless darkness between the stars. And somewhere in that darkness, in quantum vaults scattered across the galaxy, other voices are waiting, other survivors of other catastrophes, other refugees from other dying worlds, all of them part of the same vast network of preservation and survival that spans not just solar systems, but entire cosmic epochs. We're not just going home to Mars. We're going home to the universe itself. And when we arrive, we'll finally understand that we were never alone. We were never the first, and we're certainly not going to be the last. The real question isn't what we'll find when we return to Mars. The real question is whether the universe is ready for what will become when we do. The implications of what we've discovered reach far beyond just our own origins. Because if humanity really did originate on Mars, if we really are returning home rather than exploring a new frontier, then we're not the only species this has happened to. The universe is old, unimaginably old, and in that vast expanse of time, how many other civilizations have faced the same choice our ancestors did? How many other worlds have died, forcing their inhabitants to flee across the void in search of new homes? The answer might be written in the stars themselves. When we look up at the night sky, we're not just seeing distant suns burning in the darkness. We might be seeing the graveyards of countless civilizations, the scattered remains of species that once thrived on worlds that no longer exist. Each point of light could mark the location of another refugee story, another desperate journey from a dying planet to an uncertain future. This reframes our understanding of the entire cosmos. The galaxy isn't a collection of isolated star systems waiting to be explored. It's a vast network of migration routes, paths carved by countless species fleeing from disaster to disaster across billions of years. We might not be pioneers venturing into empty space. We might be following roads that have been traveled by refugees for longer than we can comprehend. Recent discoveries in deep space are starting to support this possibility. The James Webb Space Telescope has been detecting atmospheric anomalies around distant planets, chemical signatures that don't match natural processes, unusual isotopic ratios in stellar spectra that suggest industrial activity on scales we've never imagined. Even patterns of planetary formation that look suspiciously artificial, as if someone has been reshaping entire solar systems for purposes we don't understand. The standard explanation for these anomalies involves exotic natural phenomena, rare stellar processes that we haven't fully catalogued yet. But what if they're not natural at all? What if they're the signatures of terraforming operations, planetary engineering projects carried out by civilizations that learn to reshape worlds rather than simply adapt to them? Think about what this means for our own future. If the galaxy really is filled with refugee civilizations, if planetary catastrophe and forced migration are common experiences rather than unique tragedies, then our return to Mars is just the first step in a much longer journey. We're not just going back to reclaim our ancestral home. We're going back to learn the skills our ancestors developed for surviving in a universe where staying in one place too long is fatal. The quantum preservation systems we've been detecting beneath the Martian surface might not just contain the history of human civilization. They might contain a galactic database, accumulated knowledge from dozens or even hundreds of refugee species that have passed through our solar system over the eons. Each civilization adding their own discoveries, their own survival techniques, their own warnings about the dangers that lurk in the darkness between stars. This would explain why human technology has been advancing so rapidly in recent decades. We're not just rediscovering our own lost capabilities. We're accessing a library of knowledge that spans multiple species and millions of years of cosmic experience. Every breakthrough in physics, every advance in engineering, every leap in our understanding of the universe might be a gift from predecessors who faced the same challenges we're facing now. But it also means we're inheriting their enemies. Because if civilizations really do flee from world to world across the galaxy, something must be driving them, something that destroys planets and pursues survivors across interstellar distances, something that our ancestors encountered on Mars and might still be out there, waiting for us to become visible enough to attract its attention again. The evidence for this cosmic predator might already be hidden in Earth's geological record. Mass extinction events that happen too regularly to be coincidental. Asteroid impacts that seem to target the most advanced life forms of their era. Even climate changes that accelerate beyond what natural processes should be able to produce. What if these aren't random catastrophes, but signs that something is periodically culling intelligent life from our planet? This connects to one of the most disturbing patterns in human history. Civilizations that rise to great heights only to suddenly collapse for no apparent reason. The Bronze Age civilizations that vanished almost overnight. The Maya, who abandoned their cities at the peak of their power. Even more recent examples like the Easter Island culture, which destroyed their own environment with apparent deliberation. What if these collapses weren't caused by internal failures or natural disasters? What if they were defensive measures, civilizations deliberately destroying themselves to avoid attracting the attention of something worse? The same way a gazelle will break its own leg to escape a predator's jaws, advanced human societies might have chosen extinction over the alternative. If this is true, then our current technological explosion represents an enormous risk. Every radio signal we broadcast into space, every satellite we launch, every step we take toward becoming a truly spacefaring civilization makes us more visible to whatever force has been hunting intelligent life across the galaxy. Our return to Mars might not be a homecoming. It might be the moment we announce our presence to an enemy that has been waiting millions of years for us to emerge from hiding. But there's another possibility, one that's even more unsettling. What if we're not the prey in this cosmic drama? What if we're the predator? Consider the evidence from a different perspective. Mars, a thriving world, suddenly stripped of its atmosphere and turned into a frozen wasteland. Earth's mass extinction events, precisely timed to clear the stage for new forms of life. The rapid advancement of human technology, as if we're remembering how to build weapons we've used before. Our aggressive expansion into space, our plans to terraform other worlds, our casual discussions about the need to become a multiplanetary species. What if our ancestors didn't flee from Mars because their world was dying? What if they left because they had finished with it? What if the destruction of planetary atmospheres, the engineering of mass extinctions, the systematic harvesting of worlds and their resources is what we do? What if humanity isn't a refugee species at all, but a cosmic parasite, moving from planet to planet, consuming what we need and then moving on? This would reframe every aspect of human nature. Our creativity, which we see as our greatest gift, might actually be our talent for finding new ways to exploit resources. Our curiosity, which drives us to explore and understand the universe, might be our hunting instinct, constantly searching for new targets. Even our capacity for love and cooperation might be evolutionary adaptations that help us work together more efficiently when it's time to strip a world bare. The quantum preservation systems on Mars wouldn't be storage vaults containing the wisdom of a peaceful civilization. They would be instruction manuals, detailed guides for planetary consumption passed down from previous generations of cosmic locusts. When we finally access that preserved knowledge, we won't be learning about art and philosophy and spiritual enlightenment. We'll be learning about mining techniques and atmospheric manipulation, and the most efficient methods for eliminating competing life forms. The truth is, we may never know for certain whether we're returning refugees, cosmic predators, or something else entirely, but that uncertainty might be the most important discovery of all, because it means we still have a choice about what we become when we finally set foot on Martian soil again. Every mission we send to the Red Planet brings us closer to answers that will fundamentally reshape our understanding of human nature and our place in the cosmos. Whether we discover the ruins of a peaceful civilization that fled a dying world, or the abandoned machinery of interplanetary strip miners, or something we never imagined, the revelation will change us forever. The quantum preservation systems beneath Mars are waiting. The crystalline data structures are ready to download their secrets. And somewhere in the darkness between Earth and the Red Planet, our destiny is calling us home. The only question that remains is whether we're brave enough to answer that call, knowing it might transform us into something we don't recognize. If you want to keep exploring these mysteries with us, make sure to subscribe and join the journey into Earth's deepest secrets.